I don't ever slow up, no I don't take sh**. I got no love for the fakeness. If you wanna play tough and wanna hate this, I'll always show up. I don't ever slow up, no I don't take sh**. I got no love for the fakeness. If you want.
So today I want us to look at circuits, and I want us to look at circuits in big deal. Like I want us to dive in detail. I want us to be able to differentiate between parallel and series, and I want us to do a series parallel combination. Are we together? So I'm going to write a layout of all the rules for series and parallel, and then I'm going to give out Ohm's law formulas, and I'm going to give out power formulas. So let's start. We're going to lay out series parallel formulas and their rules, and then we're going to lay out Ohm's laws, and then we're going to lay out power formulas. Are we together? And then after that, we're going to do some question papers. Maybe we might do one simple one, one parallel, and then we do a series parallel question. Like this one that is in this question paper, which is 20 November 2023. So let's start. Now, for our parallel circuits, let's start with the rules, right? Series. And the next one is parallel. Parallel, right? You guys are just going to tell me what to do. Let's start with the resistance. What happens to the items in series there?
They add up, sir.
They add up. Are we together? Yes. Now, can you write for me the formula down? What's the formula for RT in series? That's all wrong, by the way. But anyways, I'm a good person. So let's move on. What happens to the resistance in parallel? It reduces. That is correct. It actually reduces. Now we've got two formulas that I want us to know, right? Give me the first formula for two resistors in series. For two resistors in parallel. Sorry.
RT is equal to R1 times R2 over R1 plus R2.
That is correct. And the other one, the longer one. The one that you can use for 20 resistors.
Right. Which brackets is that?
Yes.
It's RT equals to open bracket 1 over R1 plus 1 over R2 plus 1 over R3 close bracket to the power minus 1.
To the power negative 1. That is correct. Now let's talk about current. Who should I ask? What happens to the current in series? This one has been very quiet. Miners, how are you?
Remains the same, sir. The total.
It adds up to the. Oh, sorry. I mean current in series. It.
Remains the same. Total.
Current in series adds up. Are we together? You agree, Miners? Current remains the same. Are we together?
Yes.
So it remains the same. It does not change at all, right? Current in series remains the same. That means if they are to ask you to calculate the total resistance, just know that, if they are to ask you to calculate the total current, just remember that total current is the current before the first resistor, is the same current before the second resistor, is the same current before the third resistor. Are we together?
Yes, sir.
And what happens to current in parallel? It splits, right? So splits. Now, what is the formula? IT should be equal to?
I1 plus I2 plus I3.
Oh man, I should be a choir teacher. That sounded beautiful.
Yeah.
Lastly, let's do voltage. Now, what happens to the voltage in series? Okay, we said voltage in series. What does it do? Adds up. That means VT is equals to V1 plus V2 plus V3, right? And what happens to the voltage in parallel?
It
Remains the same. Simple stuff, huh? VT is equals to?
V1, which is equal to V2, which is equal to V3.
That is correct, right? Now let's look at Ohm's law. Ohm's law says, hey, Nancy, this question is yours. What does Ohm's law state? The formula says V is equals to? We did it yesterday. It says I times R. That is correct. I times R. This is Ohm's law. Now remember, this is the formula that I like. Because with this formula, then you can make other formulas. Are we together? In other words, it's also I is equals to V over R. Or you can also say it's also equal to R is equals to V over I. That is correct. Now let's go to the last one for power. Power is calculated as V times I. That is correct. Now my choir is broken down. You guys don't know your parts anymore. Okay, let's move on. What about if you don't have V? What's your next formula for power now?
I squared.
That is correct. What if you do not have I? What's your formula for power? V squared over R. Now let's talk about one last thing in general. Now, if you are asked to calculate the individual power, what do you take? You take the individual voltage of that resistor and the individual current of that resistor. Are we together? If you are asked to calculate power for the parallel branch, you take the voltage of that parallel branch and the current for that parallel branch. Or you take the current for that parallel branch, then the resistance for that parallel branch. Are we together, right? Or you calculate, you take the total resistance of that parallel branch and the voltage for that parallel branch. Don't mix and match. Are we together? That means don't use the total voltage to calculate the power of only one resistor, because in most cases it's not going to work. How do you know that your circuit is a series, and how do you know that your circuit is parallel? If it's series, what happens?
The resistors are one after the other.
The resistance are one after the other. Are we together? Or in other words, the wire remains straight or unbroken. Are we together? The straightness part, I don't want to say straight, I want to say unbroken, right? Because you can have something that looks like this. Is this series or parallel? Series, exactly. No, series. Because the wires remain unbroken. Are we together? Now, how do you know if it's parallel? The minute your wire splits. Can you say it together? The minute your wire splits. That is correct. So that means if your conductor is coming out like this, then your conductor splits into three. Then now this part is now known as your parallel branch. Are we together?
Yes.
Doesn't really matter how it looks like, as long as your conductor splits.
Sam, there's this homework you gave us, man. It said draw this circuit in the resistors are connected in parallel and one is connected in series.
Yes.
How do you draw that?
So if they tell you that two resistors are connected in parallel, right? So I just want you to go and they say two resistors are connected in parallel, resistor number one, resistor number two in parallel. And then they say it's now connected to another one in parallel, in series, right? Then that means that this parallel branch is connected to one in series. That is correct. That is correct. That is absolutely correct. Alright, so I'm going to draw this circuit quickly, né?
Yes.
So this is our diagram. Are we together? Then first question says calculate the total resistance for 8 months. Are we together? Calculate the total resistance for 8 months. Now here's my trick. Are we together, right? Here's my trick. Start from the furthest away from the battery. Don't start at the battery. Start far away from the battery. Are we together? So here's our battery. This is the furthest away from the battery we can go. Are we together? Then we look for items that we can simplify as quickly and as efficiently without making mistakes. Are we together? Like, let me ask you guys a question. This is how you prevent mistakes, right? R2 and R7, are they in parallel in series?
No, they're in series.
They're in series, but the wire between them splits.
So it's parallel.
So it's parallel. But if you have to calculate these two as in parallel, you're wrong. Because not only is R2 in parallel with R7, it's also in parallel with this branch, it's also in parallel with that branch. But then if we're going to look at R3, this one, R3 and this one, they are connected in series. Are we together? But then if we're going to look at these ones, they are connected in parallel and in series. Are we together? So what I want you to do is I want you to look at the small resistors that you can eliminate bit by bit. Are we together?
Is that first one 7 ohms?
7 ohms, that is correct. So what I want us to do, I want us to start by calculating these two resistors. Are we together? You see, these two resistors are clear that they are connected in. As someone says parallel series. These two, R4 and R5 are connected in series. Why are you guys saying series? The wire is not broken. Are we together? So let's call it RS1 because this is our first series circuit, right? So that would be R4 plus R5, which is equals to 2 plus 4, which will give you 6 ohms. Are we together? Now, let's redraw this second. Let's see what we've done. So this makes it easier to follow on what we are doing. Are we together? Are we together? That makes it easier for us to follow what we've done, and it makes our next step also very simple. But if you are more advanced, there's no need to redraw it. Are we together? So let's redraw this second. Are we together? Now this makes much more sense because let's give you a chance to reply his message on WhatsApp. Yes, that's you there. Okay, so let's move on, right? Now what should our next step be? Are we together? What's the next step? Looking at this second. Remember, simplification is a game. Let's not make things overly complicated. Let's simplify them as simply possible. Are we together? So remember, let's start from the furthest away from the battery. What about RS1 and oh yeah?
No, sir.
Okay. Who wants to attempt the next step? Which one? This one. These two. That is correct. Now, let's call it RP. Are we together? Because those two are in parallel. So let's calculate RP1 because this is our first parallel circuit. Are we together? So what's our formula for two resistors in parallel? It's now I meant if we were to personalize the formula, that will now be RS1 times RS6, right?
Yeah.
Because those are the two in parallel, and then RS1 plus RS6, which is the same thing as now saying RS1 was 6 plus that one is, oh sorry, it's times on top, times 5 and 6 plus 5. What do you get your answer? 13 divided by 11 is what? Oh, sorry, 13 divided by 11 is what? I'm getting 2,
So sir, I can use it as a formula also, right? 1 over RP.
yes, that is correct. So if you're using this formula, this is the only part that scares me. If you are using this formula, do not forget your minus 1. Are we together? Yes, you got 2,727 ohms.
So, sir, it's either you can do it in that long form or you can do it this way.
That is correct. Both of them give you the same answer. That is absolutely correct. Okay, let's move on, right? So let's redraw this whole thing and let's see what it looks like now, right? Now, what's the next step? R5, RP1, and R7. Are they connected in parallel or series? Series. Are you guys sure? Why? Unbroken. Are we together? So let's call it RS2, right? We're together.
Sir, I got lost there where you were adding. I don't know what you
Me
were
too,
adding.
Which part?
Where you were adding to get RP2.
We haven't done RP2 yet.
Yes,
You're saying which one are you doing? Like which series are you, which resistors are you
Or which resistors are we now looking at?
RS1.
RS1.
Yeah.
Yes, we're not doing RS2 now. Because we've already done RS1, which is this two,
Yes,
right?
sir.
Then we did RP1, which is this two, right?
Yeah.
Now I want us to do RS2. Since R5, RP1, and R7 are connected in series. I had someone say parallel. Since these 1, 2, 3 are connected in series. So let's do 1, 2, 3 in series. Are we together? So what are we going to call them? We already have RS1. We're going to call them RS2. Are we together? So let's do RS2. If we do RS2, what's the formula for resistors in series? It's
R1
plus R2 plus. Then let's personalize it. We now have R5 plus RP1 plus R7. Are we together? Does that make sense? So now it's going to be R5, we got it as 6. And then RP1, we got it as
2,727.
727, right? And then R7 was given as 5. So our total answer is going to be 13, yes, 13,727 ohms. Are we together? Okay, so now after this part, let's redraw the circuit and let's see what we've done to see if it makes sense. We're together, right? Okay, then the question is yours. You said R1 and R5. But now we don't have R5, this R5, RP1, and R7 joined to make RS2. So what are we going to do now? What's the next step?
You can do the parallel.
That's correct, right? We're going to do the parallel part. So what shall we call the parallel part?
RP2.
RP2.
Yeah, you must add the rules also.
And our formula for two parallel resistors is
R1 plus
I'm waiting you. It's
Put two.
yes, that is correct. R1 times R2 over R1 plus R2, which is this one on top, right? Now we said we're going to do RP2. R2 and RS2 are in parallel, right? So we said our formula for parallel is R2 multiplied by RS2 divided by R2 plus RS2, which is the same thing as now saying our value for R2 was given as 10, right? 10 multiplied by this one is
13,727.
727. Okay, so for those ones in the back, I'm sorry. Absolutely, sorry. And then 10 plus 13,727. Your answer will be, the answer is 5,785 ohms. Okay, that is switch. Now let's redraw the whole circuit and then let's see what the circuit looks like now, right? Because it's small incremental gains. R1 and RP2 are connected in series. That is correct.
So wait, so
Absolutely. RT is equals to now.
It's R1 plus R2.
That is correct. Which is R1 plus, if we personalize it, that would be RP2. Are we together? And our R1 was given as, and our RP2 we calculated it, we got 5.7285, sorry. 5.785. And our answer is equals to, well, I'm faster than a calculator minute. Let's do number 2, right? Number 2 is asking you to calculate the total current. Now your formula says, I was looking for the microphone. Now, what formula are we going to use to determine the total current? Now remember that all these now, right, what we talked about here, will not be applicable because in order for us to calculate IT, we need to have at least I1 or I2 or I3. If it's like a series question, almost done. If it's a parallel question, we need to have at least I1, I2, and I3. So these parts are not going to be applicable in order for us to calculate the total current. Are we together? So which are the formulas going to be applicable for us to calculate the total current? It's
I is equal to V over R.
I is equals to V over R. Now, let's personalize this question, right? The question says, calculate the total current. Total current, you call it IT. Are we together? In order for us to get the total current, we have to use the total voltage, which is VT, right? And we divide it by the total resistance, which is RT. Are we together?
Yes, sir.
Now, what is the total voltage that is given in this case? The voltage that is powering up the whole circuit, it's 24. That is correct. Divided by the total resistance. We got the total resistance as 785 ohms, right? And then you do the divisions. Your answer is 1,8. I'm just guessing. Probably 1,9. I know it's 1,9. 1,877. Nice. 1,877 amperes. Are we together? Then let's do the last question, which says calculate the power consumed by the circuit. Now this question wants you to calculate the total power. Are we together? So if it wants us to calculate the total power, what are we going to use? The total P is equal to V times R. Correct. So it should be the total voltage multiplied by the total current. Are we together? What if they want the power being used by R1? Which formula would we use?
You have to go just to the first one, find the resistance in that.
The resistance is given, so
7 ohms by
I squared R, right? Because this is our total current, and our total current is going to pass through R1. They need to split here into 2. Are we together? So if they ask you to calculate the power by R1, then I would prefer by all means we use this formula. The reason why I'll mark you wrong if you use this formula, and this formula is because the voltage here is not 24. Are we together? the voltage is going to be less than 24 because some of the voltage is going to be used by this whole part. Are we together? But you can calculate the voltage at this part if you want to. Are we together? If you want to, you can. But anyways, let's finish up. It says calculate the total power consumed by the circuit. So P total is equals to V total multiplied by I total. Are we together? And V total was given as 24. Multiplied by I total was given as 1,877.
Yeah.
And the answer will be simple stuff, right?
45,048.
Oh, serious? I didn't guess that far. 45,
078. 048.
048 watts. What's the units for power? What?
Watts.
What?
Watts.
So lesson is complete, right?